Thank you for coming to our presentation about MuLAn, a multi-layer annotated dataset for controllable text-to-image generation. Spatial controllability and prompt fidelity remain a challenge for diffusion models, resulting in counting errors, incorrect positioning, or concept bleeding. These limitations are typically addressed through scene layout conditioning or image editing techniques such as ControlNet and Instruct Pix2Pix, both of which can struggle with layout manipulation tasks. We conjecture that a key obstacle to controllability is the flat nature of rasterized RGB images, failing to leverage the compositional nature of image content. Thus, we propose to address this via multi-layer representation of images, where instances and background are isolated on individual RGBA image layers. This layer-wise representation has the potential to substantially improve image layout controllability and facilitate local editing such as replacement, displacement, modification, while fully preserving non-edited content. Research development in this promising direction is, however, limited by a lack of available photorealistic multi-layer data. To achieve this decomposition objective in a training-free manner, we design an image processing pipeline that takes as input a single RGB image and outputs is multi-layer decomposition, all while using robust pre-trained foundational models. Our decomposition module aims to extract and isolate all instances in the image. We first identify and segment instances using object detection and segmentation models. In parallel, we rely on depth estimation and occlusion ordering models to build relative occlusion graphs and establish an instance ordering for extraction, inpainting, and reassembly. Given our estimated instance ordering, we iteratively inpaint our instances' occluded areas, starting from background image to the closest instances using an increasingly richer image context. Our last module generates transparency alpha layers using image matting and accounts for mutual occlusion. It then finally reconstructs the whole RGBA stack. With this pipeline, we build a MuLAn dataset, comprising nearly 45,000 multi-layer annotations from COCO and LAION aesthetic datasets, resulting in a wide range of scene types, image styles, resolution, and object categories. Decompositions in our dataset comprise up to 6 layers, yielding over 100,000 instance images. By releasing MuLAn, we aim to facilitate research seeking to advance controllability of generated image structures and improve local image modification quality via precise instance editing. Furthermore, we hope to encourage the development of new multi-layer image generation and layer-wise editing approaches. To illustrate the potential utility of our MuLAn dataset, we provide 2 experiments showcasing distinct example scenarios under which our dataset can be leveraged. In the first application, we fine-tuned a stable diffusion model to generate images with transparency channels. Compared to the use of matting datasets, fine-tuning on our dataset yields a better quality sample with a better understanding of transparency. Our second application considers an image editing task where the objective is to add instances to an image. Instruct Pix2Pix was fine-tuned on the MuLAn dataset using the RGBA stack, where the added instance was the next one in the stack. Our model has substantially lower attribute bleeding and better background preservation when compared with Instruct Pix2Pix. This can be attributed to our training setup guaranteeing background preservation in contrast with the prompt-to-prompt editing results of the base model. To conclude, we introduce MuLAn, a novel dataset providing multi-layer decomposition of RGB images, comprising of a wide range of scene types, image styles, resolution, and object categories. With MuLAn, we aim to open new possibilities in compositional text-to-image generative research. Thank you for your attention, and please visit our poster for more details.